will be talking about something called as Bring Your Own BI. So just to give you a little more background, of course, reporting is one of the important agendas for us, and in almost all of the deployments where we talk to off-switch deployments where we talk to customers, uh, reporting is one of the focus areas for most of our customers, along with analytics, of course. And therefore we obviously need to have a reporting as a overall reporting solution in our offering. Now, uh, in fact, that's also one of the key design principles behind the optic data lake, or what we used to call COSO, right? The idea is that you consolidate data from various different data sources, definitely OPSbridge data sources at least, and then beyond OPSbridge as well, and have it available all in one common store, what we call as the COSO or optic data lake now, which then provides possibilities for doing all kinds of reporting, combining data from different data sources, and sort of cross-domain reporting, and all of those possibilities open up once we have all of the data available in one data lake. Now, in terms of the reporting solution, we of course have BVD as our out-of-box reporting solution, which provides data out-of-the-box reports for many of our data sources, and it does a fairly good job in terms of coverage of use cases. But when it comes to some of the advanced reporting needs that our many of our customers have, especially our customers have been used to and have deployed our reporting solutions in the past, like OBR, or even some of the earlier avatars of OBR, like Performance Insight or OV Reporter, and so on, have been used to the idea of having some features, including things like scheduling of reports, and cross-linking of reports, and parameter controls and all of that. And for all those advanced reporting needs, our strategy is that we recommend customers to use their own BI tools that they might have within their enterprise, and then hook that to our data store, the data lake, and but design their own reports on top of it, and meet their whatever other reporting needs that they have, which cannot be met by BVD, right? So that's the idea behind this session, and the whole strategy about Bring Your Own BI, where we encourage customers to use their own BI tools. Now, obviously, to enable customers to do that, we have come up with a white paper, right, which enables the customer to do that. And in this white paper, we essentially identify some use cases, and then showcase step by step, using some example tools, on how to build reports on top of the data in the optic data lake. The example tools that we have used are Power BI, Microsoft Power BI, Tableau, and Grafana. And the choice of these tools was based on inputs provided by product management, based on some survey that they had done with our end customers, where Power BI and Tableau came out to be the most popular. And then Grafana actually came as a demand from the field, from people like you, where you learned that a lot of customers also use Grafana. um, of course, one of the key motivations, or one of the key reasons behind it being Grafana is open source and free. So yeah, like I mentioned, the white paper goes through the detailed steps on how to build reports in each of these three tools, including screenshots and stuff. Um, and I can just show you a glance of the white paper as well after my presentation. The white paper is published on the marketplace, and there is some information and link to that marketplace also from our practitioner notes on our standard documentation doc portal. Okay, just to also give you a little more idea about the tools, at least the three example tools that we talk about in the white paper, and also for two of which we have labs in today's exercises, and I'll be also showcasing some live reports using Tableau since that is not covered in the labs. So, starting with Tableau. So in all of these tools, there is a concept of, there is a design tool, which is the tool you use to, design and develop the reports. And once the reports are designed to your liking or to your end user requirements, then you deploy them. And then there are a couple of ways or platforms you can deploy it on. One is the on-prem version, and then there is a cloud offering. And I'll talk a little bit about whether they have any free versions for you to play around with. So starting with Tableau, it has a design tool called Tableau Desktop. And in fact, it has two versions of the design tool. The Tableau Desktop is licensed, and then there is a free edition called Tableau Desktop Public Edition. The main difference between the two is that the public edition can only connect to local files on your system, right? So you can create reports of things like Excel worksheets and so on, and CSV files, but you cannot connect to a database, right? So that's the biggest limitation of the public edition. And in our context, of course, that is a kind of a showstopper, right? So because we are want to connect to the Optic Data Lake, which is the Vertica database, so you have to use the Tableau Desktop licensed version. Once you're done designing the reports in Tableau Desktop, you then deploy it either on the on-prem solution that Tableau provides, which is called the Tableau server, or you can deploy it on the cloud to a service called Tableau Online. And you might have a question, obviously, that given that our reports connect to the Optic Data Lake, and if your database happens to be on-prem, then for live reports, accessing that data from the cloud is, of course, will not work. And to provide that solution, Tableau has another piece of software called Tableau Bridge, which you need to install on-prem. And Tableau Bridge is something, as the name suggests, it acts as a bridge between the cloud service and your on-prem database, where the report in the cloud on Tableau Online uh, connects to the Tableau Bridge to request the live data that it needs for the report. And Tableau Bridge in turn fetches the data from your on-prem database and returns it to the Tableau Online report. So that's the cloud offering, and there is a corresponding cloud free offering as well. So this Tableau Online is again licensed, and Tableau Public is free. The only difference between the two is Tableau Public is truly public. So whatever you deploy on Tableau Public, everybody can see. And therefore, of course, you wouldn't want to put anything confidential there. So yeah, but for your playing around and learning purposes, Tableau Public suffices. Similarly, for Microsoft Power BI, they have a design tool called Power BI Desktop. However, the Power BI Desktop is completely free, and that's one of the reasons why we have included this in our lab. The Tableau Desktop license version comes with, I think, a 15-day or some limited trial period. So we chose to continue with Power BI as our exercise tool. So yeah, you design the reports in Power BI Desktop, and again, similarly, you either deploy it on the on-prem solution called Power BI Report Server, or in the cloud offering called Power BI Service. And Power BI 2 has a similar on-prem data access capability using a software called Data Gateway, just like the Tableau Bridge. And in terms of the cloud offering, Power BI service is licensed, but there is no corresponding free cloud offering from Microsoft. And finally, Grafana. So Grafana, it's an all-in-one tool, so there is no different design tool. So in the using the web access itself within the Grafana, you can go into the design mode and design your reports. And when it comes to the Grafana itself, the Grafana deployment, they also have an on-prem version called Grafana, which is free, and then Grafana Enterprise, which is licensed. And then similarly, they have Grafana Cloud, which is free, and then Grafana Cloud Pro, which is chargeable. So yeah, that's just to give you a brief idea about the different BI tools, at least the ones that we are showcasing in our white paper, and tools that are popular with our customers. Looking at some of the sample reports that we have either highlighted in the white paper or something which I'm going to showcase today. So here is a very simple report, standard CPU memory utilization report, charting the trend across the selected time period. So the user selects the time period over here and filters out, or includes all nodes in the reports, and then the CPU and memory utilization are charted for the selected nodes side by side. So that's a simple report. Here is a CPU and memory utilization tree map report. The tree map report especially is popular with some of our customers who are used to Cloud Optimizer, for example, where we have this tree map, which is pretty popular. And so here is a similar report for CPU and memory utilization. The way this report is designed, and as it's mentioned over here, the size of the box is determined by this number of CPUs on that server, and the color of each of the boxes is determined by the actual CPU utilization value, right? And similarly, for the memory utilization chart, the size of the box is determined by the amount of RAM on the server, and the color by the memory utilization value. And the user can select the time range for which you want to include for this analysis. So that's one tree map report. Here is a little more analytical report where if you want to analyze, how many outliers you have in your data, and by outliers, I mean, beyond a factor of standard deviation. So the way this report works is, first of all, for the selected time range and the node, it identifies what is the average, the mean value, right? So you see the center line over here, which is the mean value, which is plotted. Of course, this graph over here is your actual CPU utilization, which is plotted over the selected time range. And so, like I mentioned, the average line over here is the mean value. And depending on the user input of the factor by which you want to consider the deviations from the mean. So by default over here, for example, is 1 times the standard deviation. So based on that factor, it identifies the upper limit and the lower limit from the mean value. And it highlights all the data points that are either above the upper limit or below the lower limit, right? So the idea is basically in statistics, according to data statistics, any data which is outside 3 times the standard deviation is considered an anomaly. And so here the idea is help you identify and analyze anomalies, or how frequently you have anomalies. And the user can, so while the data statistics talks about 3 times the standard deviation, the idea here is to provide the user some flexibility to determine that factor, whether it is 1 time standard deviation, 2 times standard deviation, or 3 times standard deviation. So user can change this input between 1, 2, and 3. And the difference between the top chart and bottom chart is that this one is doing that analysis using the average value of CPU utilization. From a capacity planning standpoint, you might be more interested in doing that same analysis on the max value of CPU utilization. So this bottom chart is similar use case, but using the max value of CPU utilization. So that's the difference between the top and bottom charts. Here is another capacity planning use case that is addressed by this report. Essentially, you are identifying systems where the CPU and memory utilizations are either below the low threshold provided by the user, right, or above the high thresholds provided by the user. And again, as usual, there is a time period filter over here. And further, based on the actual value, it does some color coding, and the color coding differs for the below threshold data versus the above threshold data. So in case of below threshold, the motivation most likely is that you want to identify the systems which are, very less utilized, and therefore you identify a low threshold, provide that as an input, and then the report will show you all the systems which are below that low threshold, right? And given that you are more interested in identifying the least utilized systems, the least values are color coded as red, and it gets to was towards green, with the highest value being the greenest, right? And so that's the same for the CPU and memory below the low thresholds. And then for the tables for identifying systems above the thresholds, the color coding is the reverse, right? So the highest values are red and the lowest value is the greenest, and the others in between are shades of red or green in between. So that's that. So all these reports, by the way, so far I showcased were built in Tableau. Here is a Grafana dashboard, and this is one of the exercises in your labs. So this was built in Grafana. This is a cross-domain dashboard showcasing data from our events data. As you can see, it's highlighting over here the number of events open in last 24 hours, how many of them are in progress, and how many have been closed. And so this data is from our events data coming from OBM, which is also logged in the Optic Data Lake. And then here is the system resource data coming from either agents or sitescope. And then here is some transaction data coming from BPM, right? So over here it's identifying top 5 VMs by CPU utilization, and then top 5 VMs by memory utilization. And here is some breakdown of response time and availability for the worst performing transaction. And here is an example report which was built in Power BI. This is again it's an event summary dashboard, giving a snapshot of your OBM events volume and effectiveness. So sort of an ROI figures over here. Uh, so basically, it's showing you the number of open events which you have currently. What is the average event closure time, how many correlated events you have, and the correlation ratio. So this gives you an indication of how effective are the event correlation rules you have defined for topology based event correlation, or in the new world where we have automatic event correlation, whether there is, yeah, AC it's doing its job in terms of automatic correlation of events. So this gives you a good indication of that. And then the average response time of your operators working on the events. And these numbers, while it gives you, the effectiveness of your operators and correlation ratios and so on, um, the bottom part provides more context to this data, right? So it gives you over here total incoming events, distribution by severity, right? So how many major, critical, minor, and so on, and the same distribution for the closed events by severity. And then it also gives you an idea about the trend of your event volume, right? So the bar charts you see are the total number of just the critical and major events that are coming on daily basis, and which is superimposed by the total event volume for each day, right? So the bars are only critical and major events, and the because you might have more interest in critical major events, and then of course also the total daily events, including all the other severities as well. Okay, here is another event report which talks about incoming events distribution by different categories. So the in the top left quadrant over here, it's showing you the top 10 policies that consume the maximum event noise, right? Or I shouldn't call it noise, but yeah, uh, the policies which contribute maximum to the event volume, right? And it's ordered in the descending order of the event volume for each of the policies that you have defined. Uh, Similarly, top 10 CIs contributing the maximum towards the event volume, um, and similarly by CI type and by event type indicator. And within those bar charts, it's showing you some color coding which just indicates the event severities, right? As highlighted in the legend over here. And then the final little black line is actually the total event volume for that period. So for example, for the CI called OMI 0, in the month of January, I received so many unknown events and so many normal events, and there were a total of 35 events in the month of January for this from this CI, right? So that's what the information being provided by this report. Okay, so that's all I had in terms of showcasing, or rather the slides. So now I will also actually show you a live demonstration of how to build a report in Tableau. And let me know when you can see my screen. This is the Tableau that I'm showcasing. So I trust you see this as well. So yeah, here is the, so by the way, yeah, I can quickly show the live reports of all the reports that I showcased at the slides. So for example, here is the one we talked about, the identifying the outliers, both for average CPU as well as max CPU utilization. And here is the user input. So by default, it's at 1 standard deviation. And as you can see, I have roughly 3 and 4, 7 and 1, 8 data points, which are outliers beyond the 1 standard deviation from the average. The moment I make it 2 over here, as you can see, I already don't have any outliers beyond 2 times the standard deviation. And similarly, obviously, the range increases for 3 times the standard deviation. Um, Given that I have little amount of data in the system on which I built this report, I keep it at 1 standard deviation to just showcase the outliers, which then get highlighted. Okay, so that's that outliers report. Here is the other one which I showcased about capacity planning, where you identify systems above and below the high and low thresholds. So Okay, why is this report not showing data? Oh, it is already on the extract, so there is no question of refreshing. Okay, I will look at that later. And then here is the tree map report. The user provides the time range, and if I give 90, for example, as you can see, some of the shades are changing a little. It's hopefully discernible enough to your eyes. Yeah. So depending on that, different time range data is considered, and the color coding, like I said, is determined either by the CPU utilization value, average of CPU utilization value for the selected time period for that particular node, and similarly memory utilization value for this memory tree map, and number of CPUs for the box of the size here, and amount of RAM for the size of the box here. So this is the report which I will actually showcase building live, right? Okay. Actually, before I begin building it live, any questions so far? If not, I will continue. Okay, so here is a report which I'm starting from scratch, and rather starting blank. So the first thing is I want to connect to my optic data lake, and I'm going to connect to the same AWS deployment which you guys will be connecting to for the lab as well. Okay, so I'm connected to my optic data lake, the Vertica database. I go ahead and select the schema. So as you learn, and it's also documented well, um, all of your performance data that you would be interested in reporting would go in this MF shared provider default schema. Uh, Once I select that, it's showing me all the tables available for including in my reports. I'm going to, since we are building the CPU and memory utilization tree map, I'm going to start with this OPSB age and node hourly table, and let's say update the data. Okay, so I have the data, and I go into the sheet where I actually designed the report, right? So to include in my tree map, as we looked at this example over here, I of course need my node names, and then of course the CPU utilization value and the number of CPUs. So these three fields I need to include, and then of course the time range to filter out the data. So I'm going to start with the node name, right? And going to include my CPU utilization, and I'm just going to focus on the overall CPU utilization average value. I'm going to include that now. So this is my node and my CPU utilization value. As you can see, my CPU utilization currently doesn't make sense. It's more than 100. That's because by default, the tool has used the aggregation of sum. I want average, and now it's the average percentage. So I do that, and I want a tree map. So I'm going to change this visualization to use a tree map. Now, by default, since we haven't selected the number of CPUs, by default, it's using the the CPU utilization value for both, determining the size of the box as well as the color. And by default, it has picked some default coloring scheme. Uh, Now, as you can see, currently this is the biggest box because the CPU utilization value of this server, average CPU utilization value is the highest. It's 48.26, as you can see in the tooltip, and for the others, it's much lower than that. And therefore, you see this box being one big box and also being the darkest because its value is the highest. We want to use the CPU count to determine the size of the box. So here is my field which gives me the number of CPUs on the server. Now, if you notice, currently this Pu01 VM is the biggest box. The moment I use this, first of all, I want to make sure that it doesn't do any aggregation on this field. So I'm going to change its aggregation to use maximum, although all the values are same across data points because it's just the number of CPUs on that server, so it doesn't change. But I don't want, obviously, Tableau to do either an average or sum of it, so just choose the maximum as the aggregation. And then now I drag and drop this field on this size mark, right? So now, as you can see, the Pu01 VM box is no longer the biggest because the number of CPUs is what is determining the size of the box now. And this server has only 4 CPUs versus these other ones have 16 and 8 CPUs. Okay, so we did that. So now our boxes are sized by the number of CPUs and color coded by the CPU utilization value. So that's that. And then I want to include some time filter, right? Um, Actually, I'll come to that time filter after I also finish building the memory chart. And the reason I will do that afterwards is because I want that time filter to apply to both the charts once I include them together in one dashboard. And to be able to do that, I will define a parameter so that both can refer to that parameter and find or consider timestamps which are greater than the last number of days input provided by the user. So I'm going to create one more sheet for the memory utilization tree map. And this time I'm going to add a new data source because I'm going to use a different table. And this, yeah, I'm doing that just to also showcase that how you can include multiple data sources in your reports, right? And combine data from different data sources. Okay, so again, I connect to the same schema, and I find my OPSB sys infra node table. Again, I will choose the hourly aggregated table. So this, by the way, I hope you know that, and this is also documented in our schema documentation, that the table names have some sort of naming convention, right? So it's easy for you to identify which table to pick for your use case. So over here, it's fairly obvious. This is a table for the OPSPitch data for system infrastructure, so system resource metrics, and then what exactly is the metric in this table from system resources. Over here it's disk, over here it's file system, network statistics for each of the servers, and here is a node one which has the node level metrics for CPU, memory, and disk as well, I think. So yeah, that's just to highlight that we have a naming convention which makes it easy to identify the tables you need to pick. Okay, update the data. Okay, so now I have included this new data source called, so all my data sources which I have included are here. And now I want to, for the memory utilization tree map, I want to include from data from this table. So again, similar, I want my node name and my memory utilization value is here. I'm going to mark that please use average as the aggregation. Okay, so I have my memory utilization and node name, and again I'm going to change it to tree map. And again, as you can see, both the color as well as the size of the box is currently being determined by my memory utilization value. And again, this same server happens to have the maximum memory utilization and therefore the biggest box. Now we want to size it by the amount of RAM on the server. So again, I go with memory physical max. Okay, and now that same server is no longer the biggest box because it has only 8 GB of RAM versus others have a lot more memory. Okay, so I have the memory chart as well. We can of course change the color coding over here. So let's use the red green because that's people are most intuitive. And over here it's showing low value as red and high as green. We probably want reverse if you want to identify really heavily utilized systems as red, something we don't want. And you can determine how many shades you want of the color coding. Okay, so that's that. I'm going to do the same color coding for both the charts. Okay, and yeah, like I said, I want to include a parameter to determine the number of days to include in the report. So I'm going to create a new parameter. I'm going to call it last days. Okay, and I want to keep it as range. I don't want user to analyze, let's say, beyond the last 90 days. Then I can do that over here. I will leave the step size as it is. And let's say by default, we want to start at 30 days. Okay, so I've created that parameter and let's say show the parameter so the user can see the parameter. Let's change that the user can type in the number of days. I don't want a slider, so I've done that. And now I obviously want, so currently I've just created the parameter, but the data is actually not considering this parameter, right? It's not using this parameter. So I need to do that. For that, I need to create another calculated field. And I'm going to call this date range. And I'm inside the CPU utilization chart, right? So, and the criteria is that my timestamp is greater than or equal to the number of days, what from today minus the number of days and whatever date you get. So my timestamp should be greater than or equal to that date. So the user is providing input in terms of number of days. So I want to do this day math at the day level. What is the interval is going to be provided by the user using that last n days parameter, right? So, and it's negative because I want to subtract and not add. So I'm going to subtract that. And here is my parameter, right? Last n days. So I'm going to say that. And then from which date onwards? So that would be today's date, right? Uh, okay, what are the errors? All fields must be aggregate constant. did I not? I did include from here, right? Date range CPU. Just a second. Let's check also in our out of box report. What's the missing here? So if I go here, not the filter, but the I am using that. Let's just start afresh. I am in the agent. Yes. Timestamp. Okay, that's day. Let's try one more time. Okay, that's not good. Okay, I'm just going to say okay and just verify is it a data type issue. Okay, let me make this integer. Does that make a difference? Where is my okay? Oh, maybe it was the case. Okay, it was the case of this not being an integer. All right, so because data add only expects integers over here. Okay, so now the calculation is valid. So I have defined this field, which is essentially calculating and filtering out timestamp, which is greater than or equal to my date for last 30 days, right? And now I obviously need to include that as a filter, and I want to include only true values. Okay, so now the user will be able to provide any inputs, and let's see, first let me give a maximum value. Okay, I hope you saw a little bit of shade difference. Let me make it now some small value like 12, and yeah, you can see especially this box, the shade changes a little bit. Okay, and I'm going to do that same thing. I'm going to include this parameter in this memory chart as well. Let the user provide the input, and same thing. Interval is determined by my parameter from today. Okay, it's valid, and I'm going to include that as my filter in this one. Okay, again, let's say I give 12. You can see the shades changing for many of these boxes. Okay, so now I have, and let me just name them appropriately. This is the CPU tree map, memory tree map. And now I'm going to create a dashboard which includes both of these together, right? So to begin with, I'm going to have a title for my report, CPU and memory utilization tree map. Yeah, let's have something bigger. Okay, and here are the two sheets which I've defined, right? The CPU tree map and the memory tree map, which are available for me to include. So I'm going to include the CPU one first. And here is my filter for last n days. And this is my legend. We'll put it appropriately somewhere afterwards. And let's say please cover the whole area. Okay, so this is my CPU tree map. I'm going to include my memory tree map here. Fit the whole view. Okay, so I have my chart ready, and now you should be able to see the shades changing in both the charts depending on the input provided by the user. So if I take 15, okay, and now if I say 90, yeah, I hope you can see the shades changing. Okay, so that's essentially my report is ready as per the use case we had identified. Now obviously we can play around with the cosmetics and background and adding logos and stuff as much as you want, but from a use case perspective the report is ready. So yeah, that's pretty much I wanted to showcase. Any questions? Okay, let me look at the chat if there are any questions. Okay, Sudarshan is asking if customer doesn't have his own BI tool, then we offer them BI tool in bundle with COSO BVD. No, we don't. Okay, Arun has already answered that. BVDs are of course the offering, um, but yeah, you can use Grafana if you want a free tool. Um, Akash is asking, and Steve has already answered that. Okay, yeah, so Steve has appropriately answered it, so that's good. Priyanka is asking, how would the standard deviation for outliers be devised, which should be right for the nodes? That's a good question, Priyanka. So this is going to be, the need is obviously going to be determined by the customer based on their requirement. Um, like I said, if purely from a data statistics standpoint, they considered anything more than 3 times the standard deviation as outliers. But you might have different needs and identifying the outliers, and maybe all you want to do is analyze why you have certain outliers at specific points in time. If that's all your requirement, then therefore, we provide the interactivity in the report that the user can do the analysis based on different factors of standard deviation, 3 being the maximum, because anything more than that doesn't make sense. I hope I answered that, Priyanka. Kiran is asking, how are the reports shared and are the reports real time? So first coming to sharing. So yeah, both Power BI and Tableau have so when you design this report, so in Power BI, for example, and then let me show you, for example, okay, so hope you can see my Explorer. So I have something called as my Tableau repository, and then in Tableau there is something called as workbooks, and here is, for example, the uh, system resource work reports that I was showing. So all of the workbooks are called .twb, which is nothing but like a template that Tableau ends up creating. And we can just share this workbook with anyone. And obviously they just need to change the connection details to now point it to their database, because currently the workbook would be pointing to the designer's database, right? And once you have this workbook, then and you connect it to your database, you have the report ready. And Power BI has something similar called as a PBIX file. Uh, so so yeah, sharing is easy. You just share this workbook with the customer or whoever you want to provide it to. So that's the first part of your question, and the other one is, are the reports real time? Yes. So let me show that. I forgot mentioning that when I. So as you saw, when I connected to the database, there are two options over here. One is the live and the other one is extract option. So if you leave it at live, that means yeah, the data connection is live, and uh, you can refresh the report at any point in time, right? You can just click on here and say refresh the data source, but that is just because you're in the design tool. Once you deploy this report to Power BI online, as and when you open the report, it will be refreshed based on the current data in your database. So it is live in that sense once deployed. And you of course also have the option of not keeping it live, right? So you can extract, and based on the current filters defined in your report, the data will be extracted, and you are working off that extracted copy of the data as opposed to a live connection. So you have both the options. Uh, okay, so I hope I answered that question, Kiran. Chandrakant, are there possibilities to create SLA reports, specifically system availability and penalty calculation in same SLA report? So if for availability, for system availability, first of all, we have uh, reports out of the box in BVD available, but nevertheless, as you can see over here, there is the system availability tables available over here, right? So you can of course create let me create new data source, and I connect to the same data source. And yeah, I mean, all I wanted to showcase was that there is availability tables, availability data readily available in the Optic Data Lake for systems, right? And you just have to design report on that table. So sys infra availability, right? So you just create reports of that and design your report. So you, in terms of availability, you have now SLA and penalty calculation is something, there is no readily available SLA configuration or definition, and hence any penalty calculation available out of the box in the Optic Data Lake. So you obviously have to, you know, based on your use case, you would have to create some calculated fields, right? Where you define a penalty, for example. So if CPU utilization is not CPU utilization, rather availability, right? Sorry. Where is my availability? If my downtime percentage, for example, is less or greater than 1, then okay, if downtime greater than 1, then whatever my penalty is, I don't know whether you measure in terms of dollars or whatever, or currency or something else. Let's say the penalty is 100, right? uh, Else nothing, or you can just end it here. Okay, and then you include this penalty in your report. So this is how you would go about doing it in a BI tool. And similar ways of course all of their tools have their own ways of doing things, but essentially all of this is possible in almost all BI tools. And in Grafana, it's of course a little more different. You don't drag and drop and design fields like this. You write SQL queries directly. So then you have a lot more flexibility, as long as, of course, you know SQL. So that would be kind of a prereq for designing reports in Grafana. But in the other BI tools, you have these possibilities. Okay, so I hope I answered that question, Chandrakant. And so that's all. Then I will stop sharing, and I think Alexi, they can now do the labs, right? One of your co-participants, Arun, is also one of the authors of this session and the labs. So Arun and I are here to help you with any questions on the labs.
All right. So thank you so much. And let me stop the recording. And actually, our next thing is a performance dashboards